Hi, it's Mr. Anderson, and this is AP Physics Essentials, video 104. It's on wave period and frequency. Period is the time between oscillations in a wave, and frequency is going to be how many oscillation or waves do we have per unit time. Now, it's sometimes easy to confuse frequency with the velocity of the wave, and so we're not even going to start with waves. We're just going to start with some flashing lights. And so the light on the left is flashing. Try to figure out the period. How much time is there between each flash? And the right answer is there's 1 second. And so the period, or capital T, is 1 second. There's a flash every 1 second. That's the period. What's the frequency then? Well, we're having the flashes, and so it's how many flashes we have per second. And since we have one flash every second, our frequency is one flash per 1 second. Now, the units for that is going to be in hertz. And so our frequency is 1 hertz. Now let's look at the other light. And so it's flashing as well. Try to just figure out what the period is. You can see it's slower. And so the period in this case is going to be 2 seconds. So it's taking twice as long between each of the flashes. So what's going to happen to the frequency? So now we've got one flash per 2 seconds, and so what's going to be the frequency? It's going to be 0.5 hertz. And so period and frequency will always be the reciprocal of each other. Once you know period, 1 divided by period is going to tell you the frequency and vice versa. And so waves transfer energy through oscillations. The wave period is going to be the time between the waves, and then the wave frequency is going to be a wave, or a set number of waves, per unit time. Now we measure period in seconds, and then we're going to measure wave frequency in hertz, which is the number of waves per unit time. Now, if you're ever looking at a wave diagram like this, the first thing you want to do is figure out what are my axes labeled. And so the position is changing here, but this is over time. Now, you could also have wave diagrams where it's position here and position here. But since we have time on the x-axis, if I want to figure out what the period is, I simply measure the distance between waves. And so I find one wavelength, so one oscillation, and then the distance between the two is going to be the period, or it's going to be the time. If I wanted to figure out the frequency, then it's simply the reciprocal of that. And so let's do a little simulation. This is a PHET simulation. What I'm going to do is generate some waves. And so those waves are moving from left to right. And so this is going to show us the position, but it's going to have a certain frequency and therefore a certain period. Now, a way to see that is to slow it down. Since we're looking at a position of the wave over here, I've also added a clock. And so we can keep track of that time. And so we're going to create one wave. And so I'm going to stop it after we go through one oscillation. And so what's going to be our period? Well, we've got the one wave here, but what's the period? It's the time. It's simply 0.67 seconds. And so that's the time distance between waves. We're just about to start another wave. Now, if I want to figure out frequency using this simulation, what I could do is just let that clock run until it gets to 1 second. So I've stopped it here, so that's 1 second. And so how many waves do you see on the screen? Well, I see 1.5 waves. And so our frequency is going to be 1.5 hertz. Now, we could have done it just by looking at the simulation, doing some experimentation, or we could just do it mathematically. If we want to convert from 0.67 seconds into frequency, all you do is we would take that period that we calculated, 0.67 seconds, we take 1 divided by 0.67 seconds, and we'll get 1.5 hertz. Let's say you're given a problem and you want to solve what the period and the frequency are. The first thing you want to do is look at your axes. And so we got meters here, and then we've got time. And so if I want to figure out the period, remember I just find one wavelength. And so I could say right here is the top of one, and we go back to another top. So this one's at 25 seconds, this one's at 45 seconds. So what's my period going to be? It's going to simply be 20 seconds. If I want to figure out what the frequency is then, what's the easiest way to do that? Well, once I have my period at 20 seconds, I simply take 1 divided by the period, and I'm going to get a frequency of 0.05 hertz. And so did you learn to use a graphical representation of position versus time to calculate the period and the frequency? I hope so, and I hope that was helpful.